All right, welcome back. So this video is going to be an explanation video for this practice quiz that I've made. And basically I'm going to try to talk through my thinking for each problem. So it's going to be a little bit longer of explanations, but hopefully you'll find that helpful. So we've got the first page here, questions 1, 2, and 3. We've got sort of a variety of different problems, and then on the back side we've got some mass percent and mole concept type problems. So let's go ahead and get started. The first question says a given metallic cation. So just sort of looking at it, cation essentially means I'm going to have a positive charge ion, and we've got our charge of +4. Has 19 electrons and 28 neutrons. This 28 neutrons is actually just sort of a distractor. It's actually not important for this problem at all. Let's put our name on. So really the relevant information here is +4 and 19 electrons. And if I'm trying to identify the metal, that's going to be sort of figuring out the number of protons. Each different metal, each different element is really identified by the number of protons. And if I have a +4 charge and 19 electrons, well then that essentially is telling me I should have 23 protons. Because if I had 23 protons and 19 electrons, I would have an overall +4 charge. So sort of just figuring that out is the key to this problem. Obviously, there's not that much math involved, but just sort of knowing conceptually what's going on. So then I need to figure out, well, what chemical species, what element has 23 protons? So if I go over to my periodic table, I can see that vanadium is number 23. That means that it's got 23 protons. The correct answer here is E, none of the above. For the next question, which of the following would you predict has the greatest lattice energy? So lattice energy is going to be related to how stuck together our two different ions are. It's going to be related to ionic attraction. So the greatest lattice energy means that it's going to be the most stuck together. This is also going to mean that it has the highest melting point. It's going to be the hardest to break apart, so it would have the highest melting point as well. So we're going to see those two concepts sort of go together. So the first thing when we're thinking about lattice energy that we're going to think about is relative charge. So +1 - 1 versus +2 - 2, so on and so forth. Second, we would have to consider size. So if I've got, if I'm comparing a series of +1 - 1, +1 - 1, and they all have the same charge, then I'm going to sort of default to, okay, well, which ones are more stuck together based on which ones are closer together. So the smaller the size, actually the closer they are together. So if I look through my list here, lithium fluoride, magnesium oxide, sodium chloride, potassium chloride, the first thing that I'm going to do is think about what the relevant charges are. So lithium fluoride is going to be +1 and -1. So lithium, fluoride is an ionic compound. I can see I've got a metal and a non-metal. Lithium is in group 1. All right, we can look at our periodic table. Lithium is here. All of these things in group 1 are going to have a +1 charge. Fluoride is in group 7, -1 charge. Magnesium is going to be +2 - 2. Magnesium oxide +2 - 2. +1 - 1, +1 - 1. Magnesium oxide is going to be the most stuck together. So it's the only one that's a +2 - 2 charge. So since that's the first thing we're going to look at, I can tell right away that means that it's going to be the most stuck together. That's going to be our greatest lattice energy. Now, if I wanted to compare lithium fluoride, the remaining things, lithium fluoride, sodium chloride, potassium chloride, I'm going to look for the smallest one. So if magnesium oxide wasn't here, if it wasn't a choice, then lithium fluoride would be the next best choice. It would be the most stuck together. All right, some naming here. Provide the name or formula for the following compounds. Potassium sulfate. So something that I might do if I was going to be doing this problem for the first time is I might write out above my names what the sort of relevant information is. So for potassium, I recognize potassium sulfate as an ionic compound. I've got a metal, I've got a polyatomic ion. I recognize sulfate as a polyatomic ion, SO4 with a 2- charge. So for potassium sulfate, I'm going to need 2 potassiums for every 1 sulfate to balance out. Overall, I've got to have a neutral chemical formula. So since potassium is a +1 charge, sulfate has a 2- charge, then K plus SO4 2-. Beryllium cyanide. So again, I'm going to sort of have to figure out, well, what's the charge on cyanide? I know that that's Cn-. Beryllium's in group 2. Right, it's number 4, so it's going to form an ion with +2 charge. So BeCN2, beryllium cyanide. Here I've got iron oxide, so I need to recognize Fe as iron. And then this is going to be iron 2 oxide. So I need to indicate the 2 because iron is a transition metal. So I need to indicate iron 2 oxide for the oxygen there. The last one, I recognize this as a molecular compound. So this should be dinitrogen trioxide. So dinitrogen trioxide. For our molecular compounds, that's when we're going to use those Greek prefixes di, tri, tetra, so on and so forth. So I'm actually going to cut this video off here. I'm going to make another video. I'll link that to this video for the second half of this practice quiz. So I'll show you those questions real quick. They are just some mole concept question and then a mass percent question, but I'll make another video for that.